Okay, welcome to the study hall on November 7th. The topic for today is a continuation of the topic from last time, which is the C trap in data sufficiency. And again, if you just arrived, when there are multiple choice questions, please find the multiple choice options underneath your name, A through E. And also, please only click one time. If you click twice, then the second click will actually take away the answer you clicked on the first time. So if you have an option, click on it once. If you want to change your answer option, click the new one once. If you click more than once, then every even-numbered click will kill the old click. So, all right. There we go. Let's go ahead and do a problem. And again, remember, don't forget where the multiple choice question answers are, please. Okay, try this problem right here. And again, don't forget where the multiple choice problems, don't forget where the multiple choice responses are located. Okay, here's a timer. Go for it. Okay, so our answers here are kind of all over the place. There's also a lot of you guys who don't yet have answers, so go ahead and pick one in the next 20 or 30 seconds. And okay, don't forget the way this test works. The GMAT doesn't allow you to not pick an answer. Like you have to pick something, otherwise the problem will just sit there and stare at you until you pick something. So if this is a data sufficiency problem, we do expect you to be familiar with the way these problems work. If anybody doesn't remember what the choices are, I can go ahead and put those on the board. But as far as the way that these data sufficiency problems work, we do expect you to be at least fundamentally familiar with what the answer choices are. But if anybody doesn't remember those, then here they are. Different combinations of sufficient and insufficient. So if any of you need these, please write them down, because all of today's problems are data sufficiency, and we're not going to keep putting these on the board. So, okay. If you need to pick a choice, please pick one, and then we'll talk about the problem. Okay, so here are the answers from the class. There. So I'm noticing, by the way, it seems like people are not so much paying attention to what the topic of the class is. So let me just flash that home screen at you again real quick. So today's topic is the C trap, continued. The C trap means that, choice C is not going to be the right answer to these problems. And we're going to talk about why as we go. But these are all going to be problems that have the same type of trap in the answer choices. So, and that's going to be choice C that's going to be the trap. So it's interesting that the most tied for the most popular choice here was our friend choice C. Don't let it happen again, because that's the topic of the day. Okay, let's see why. So here's the problem. Okay, let's talk about first of all, let's talk about how the problem works, and then we will go ahead and review what it means for choice C to be a trap. But let's talk about this. So first of all, sequence notation. One of the biggest issues with sequence notation is that it's weird looking. Same thing with F notation for functions and so on. Like if you see sequence notation, then just make sure you know that one of the primary challenges here is just going to be decoding what that notation even means. So one of the primary challenges is just understanding what the notation means in the first place. And so if you get to that point, if you get to the point where you understand what the notation means, then you've actually, or you're about halfway there. So just make sure you know what this is. There's actually a whole session about sequence notation in the Thursday archives if you're less comfortable or less familiar with these. What does this mean? This means that, that's not what we're doing yet. Okay. I mean, this notation means, what, does anybody want to tell me what this means when you have an A sub n and you have an A sub n minus 1? Like, what is going on there? In the chat box, if you want to explain. Yeah, it's like a previous number in the sequence, PLKT or PIKT. That's a term that applies to this sort of special thing. But in general, when you see an n and n minus 1 in your terms there, this is the, I mean, what this means literally is this is term number n. And this means term number n minus 1. But if you think about what n and n minus 1 means, then you'll figure this out, which is this just means any term and the term before it. So you can think about this as any given term of the sequence. And then John LOL, if you can tell me what's funny, that would be, I don't know what's funny about this, so if you're going to tell me, that'd be cool. This means any given term of the sequence. My voice is weird. My voice is very weird, I know that, but maybe is my voice coming through weird? I don't know. Okay, term number n means any given term of the sequence. And then term n minus 1 is the term before it. If I sound like Bugs Bunny, that actually means you lost your connection. That's the way the software works. If you lose your connection for a second, then it will, the software wants to make sure that you actually hear everything that was said. So if your connection is interrupted, then it will actually play everything back faster so that it catches you back up. So that's what the high voice means. So there you go. Okay, unless I sound like that to everyone, in which case that means that I lost my connection for a moment. Okay, so this means for any given term of the sequence, it's equal to the previous one plus some constant. So what that means overall is that you have a sequence that goes up or down by the same amount every time. So there are quite a few questions about sequences like this because they are nice and they are full of patterns. So, I mean, you can just keep adding the same amount every single time, or keep subtracting the same amount every single time. So let's talk about that. The question, by the way, is how many terms in the sequence are greater than 10. The other thing that is a very big deal in data sufficiency is the ability to focus on the questions. Hold on a moment, please. All right, so remember that if you are not answering the right question, which people very commonly don't, then you're going to be in trouble here. Like, you don't want to know what all the terms of the sequence are. You just want to know how many of them are greater than 10. So just note, in data sufficiency in general, if you are trying to answer any question other than this, you are in big trouble. So in particular, if you are trying to find all of the terms of the sequence, then you are in huge trouble. Beware. So in general, you find the answers to data sufficiency questions without finding all this extraneous information. So we're probably going to get an answer to that without actually finding all of the terms. So that's what you should expect. Okay, let's talk about what this means. So this means we have a sequence that goes up or down by a constant, but we don't know what the constant is, and we also don't know what any, to start with, we don't know what any of the actual numbers in the sequence are. So statement one says that the first term of the sequence is 24. So, and remember what we're trying to do. If we can get two different answers to this question, then that's not sufficient. And if we're stuck with one answer to this question, then that's sufficient. What do you guys think of that? Like, what's going to happen if I start with 24, then what's going to happen if k is positive? If k is any sort of positive number at all, then what will my sequence do? People are typing in the chat box. Yeah, the terms, it'll just keep going up, right? So, like, for instance, the answer to this question, and by the way, how many terms are in the sequence in the first place? Let's talk about that. How many terms are there? There are not 14, actually 15. Because you have to define n all the way from 1 to 15 for this to, I mean, for this to make sense. Because, I mean, this definition says 2 through 15. But notice, if n is 2, then you actually need to have the second term and a first term. Also, by the way, we are talking about A1 here, which means that A1 definitely has to exist. So if you thought that we started with A2, then this would be a meaningless, weird statement. So that's not going to happen. So we start with A1. If n is 2, we have to have an A2 and an A1. And then we end with A15, so because that's 14 and that's 15. Other way around. If it's 15, that's 15 and that's 14. So the terms go from A1 to A15, not A2 to A15. Make sure you know that. So the first term of the sequence is 24. So for instance, let's just test cases. If, for instance, k is 1, then your sequence is 24, 25, 26, blah, 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 all the way up to 38. So you don't even have to figure out that it's 38, but all of these terms, which is 15 of them, are going to be greater than 10. So now, as soon as we have gotten this to happen, remember what the goal is. The goal is to try to get another answer, because if we get an answer that's not 15, then insufficient. If we keep getting 15 terms that are greater than 10, that's not going to help us. So the goal is to get a different answer once this happens. How do we get a different answer? Tell me in the chat box. Yeah, you make some sort of negative value of k. So yeah, Yannick testing cases, but tell me what kind of cases, right? So like, let's just pick a negative value of k. Like for instance, if k is minus 10 or something, then k equals negative 10. Then you have 24, and then your next term is 14, and then your next term is 4, and then your next terms are minus 6 and minus 16, and so on. So in that case, only 2 of those terms, the first 2, are greater than 10. So we've proved that statement 1 is not sufficient because we've got 2 different answers here. I mean, you can have a lot more than 2 answers. In fact, anywhere from 1 to 15 of these terms can be greater than 10. So, but as soon as you get 2 things to happen, you have established that it is not sufficient. So, not sufficient. Okay. If you know about the grid device that we use for data sufficiency, then you can make that device A, D, B, C, E. Since that's not sufficient, we can scratch A, D. Let's address this question in the chat box from Zach. Zach, remember the discussion up there of what this means in the first place, right? So does it have to go in order of increasing or decreasing? Well, check out the definition here. Not definition, but check out what's in this yellow box up here. I mean, K is a constant. So remember what constant means. Like constant means it doesn't really change as you go. So in your example here, the problem is that if A1 is 5, if you go from 5 to 3, then this would imply that K is -2 because you're just these 2 terms. Those 2 terms would need K to be -2 because you are going down by 2. And then if the problem, though, is that your next 2 terms would require K to be +4. So this is, in this particular problem, this is not something that can happen because you need to be going up or down by a constant. Sequence in a greater sense, I mean, a sequence in a greater sense could be absolutely any sequence of numbers in the world. Then, yeah, in a greater sense, you don't have to go in order. But in this problem, because of the way they defined the sequence, you do wind up going in a decreasing or an increasing order. But in general, no. In general, you could totally have a sequence that does that. So, for the sake of completeness, in general, sure, a sequence can have any numbers in any order. Here, because of the equation above, you end up continually increasing or decreasing. So, okay, I hope that answers the question. Okay, so in general, yes, but here, no. Okay, let's look at statement 2 real quick. That was sort of a weird thing. Okay, so let's look at statement 2. Let's take this over to the next page. All right, there's the problem. Let's look at statement 2. Statement 2 says that A8 is 10. What is special about A8? Yeah, it's the term that's in the middle of all of this stuff, right? I mean, remember that there are 15 terms. So that means that you have A8 is a very special animal because A8 is the one that has 7 terms before it and 7 terms after it. I remember when you do data sufficiency problems, you do need to think about whether the numbers that they are looking at or the numbers that they're picking are special. So yeah, why are there 15 terms? I mean, again, remember what this, I mean, okay, first of all, when you, yeah, we can go over this again. I didn't write anything down the first time I talked about this, so maybe not everybody caught it. The question is, how do we know there are 15 terms? Well, one general observation, by the way, I've never seen a sequence on the GMAT start with anything but the first term. So it's likely that every GMAT sequence that you ever see will start with term 1. But so just make sure you know that in general before we talk about this one at all. In general, GMAT always seems to start sequences with A1 because they don't really want to trick people. I mean, the one thing that these questions don't do is define things in very weird ways. Like, I mean, in a math textbook, you might see a sequence that starts with A13 and ends with like A28. But here, you're not really going to do that. But as far as the way this definition works, notice that this has to work. This definition has to work for all of the numbers in this range. So the bottom number in this range is 2. But think about what happens if it's 2, right? So you've got if n is 2, then this says A2 is A1 plus constant. So I guess we need to have an A1 because it exists, it's a thing. And then if you look at John, that's not the right explanation because we're looking at statement 2 right now, and you are not given A1 the problem. So no. But it's the fact that there are 15 terms is inherent in this statement and this statement only. Like as soon as you have whatever is in this what just happened? Okay, something. Someone is teleconferencing. I don't know exactly what that means, but okay. Just from what is in this purple box, you already know that there are 15 terms. Like it has nothing to do with what they tell you about A1 or A8. So, okay, because you just look at the lowest and highest ends and see what you need for those to be meaningful, right? Like if you have n is 2, then you need an A2 and an A1. And if you have n is 15, which is the top value, then this says A15 is A14 plus k. So, I mean, in order for this to mean anything at all, we have to have terms 1 through 15 because we just have to have those. So we have 15 terms. That is, if that takes you a while to figure out, then take a while and figure it out. Because if you don't figure this out, then the whole problem will not make sense. So there you go. You got to have terms 1 through 15. So there are 15 terms, and so notice that A8 is sort of a special animal here. You're welcome. What's special about A8? Well, notice that there are terms 1 through 7 before it. And then there are terms 9 through 15 after it. I mean, terms 1 through 7, there are 7 of those. And then 9 through 15, I mean, I would just count those on my fingers. 9, 10, 11, 12, 13, 14, 15. There's 7 of those, too. So, oh, look at that. It's the middle term. That's the key fact here. I mean, yeah, 15 minus 9 plus 1, but I mean, my brain doesn't really hold formulas like that. So, I mean, honestly, dude, it's 7 things. I'll just count them on my fingers. It's a lot faster than doing that. But if that works for you, then you should do that by all means. Okay. So what does that mean? Well, let's say that, so statement 2, what happens if k is anything that is positive? What happens? Chat box. Yeah, if k is anything positive, then that means your sequence goes up the whole time. So that means that terms number 1 through 7 are less than 10. And that means that terms 9 through 15 are greater than 10, because term 8 is 10. So that means that 7 terms are always more than 10. That's going to happen for any value of k whatsoever. Like if k is 0.001, then the first term is going to be, 9.993, and then you'll have 9.994, 9.995, blah, blah, blah. And then you get to 10, and then 10.001, 10.002. You could also have k as like a million, billion, trillion, and then all the 7 first terms are huge negative numbers, and all the last 7 are huge positive numbers. But it'll always be more than 10 on the right of it and less than 10 on the left of it. So you just got to think about negatives. If k is anything negative at all, then terms number 1 through 7, what will happen if k is negative? Yeah, if k is negative, that just means you're going down instead of going up. So if k is anything negative, then terms 1 through 7 are greater than 10. And terms 9 through 15 are less. So there's still 7 terms less than 10. If you were allowed to make k 0, then that would just spoil the party for everybody, because then all the terms would be 10 and none of them would be greater than 10. But you're not allowed to make k 0 because, well, they told you that you can there. So that's not an issue. Make sure you would think about it if it was an issue, but here it's not. So I guess it's sufficient. I mean, you know, always with this statement, you're going to have 7 terms that are greater than 10. So sufficient. And that means overall your answer is B. Any questions about how this problem works? Any questions, type them in the chat box. If not, let's make some observations about how this problem works. The problem is not displaying, it's probably just you, sorry, because if it were not displaying for anybody, then a lot of people would be yelling through the chat box. So, probably just you. Okay, let's look at some consequences of this. So remember what the theme of the lesson here is. Okay, we're talking about the C trap in data sufficiency. So let's remember what that means now. So was anybody here in the last session where we talked about this for the first time? Does anybody want to summarize what C trap is? Okay, if anybody remembers what the basics were, you can feel free to summarize. Here's a new page. Here's the problem again. Let's discuss the consequences. Yeah, so that's, if you remember, the users who are posting chats right now are doing a pretty good job of summarizing what the takeaways were from last time. But just make sure you know this, right? As a build up to this discussion, like the one thing you really have to realize about data sufficiency problems is that they are very focused. Okay, just remember this. Because this is why the C-trap is a C-trap. I mean, remember that the primary purpose of data sufficiency problems is not to test mathematics. The primary reason why data sufficiency is on the test is to test focus on a particular goal. So in this case, that goal is how many of the terms are greater than 10. Notice what the goal is not. The goal is not to find the entire sequence. So here, the goal is to find how many terms are greater than 10. And just as importantly, the goal is not to find the entire sequence. If you think you're trying to find all the numbers in the sequence, then you are basically ignoring what the problem says, and that is a bad thing. So yeah, Naga, that's a pretty good summary of what's going on. So notice, let's talk about answer choice C here. I mean, if you pick answer choice C to this problem, which a lot of people did, even though the theme of today is C is a trap, a lot of people still picked it. Notice what happened. I mean, here's all you had to do. You had two terms. You know that the jump from one term to the next is always the same. So what that means is that you know the entire sequence. I mean, if you had choice C, then you actually find out what all the numbers are. I mean, you don't actually have to find them, but that's what the problem is. If you pick choice C, then you don't really have to think about this issue, because you would have an entire sequence, and so the question, you don't have to focus on the focus anymore. Like, if you have the entire sequence, then the particular question that they're asking becomes unimportant. And I mean, that's not good. Like, one thing that will definitely not happen in data sufficiency is that the particular question that they are asking won't matter. So if that happens, like, in other words, you don't have to actually think about how many terms are greater than 10 if you pick C. And that's why you know C is a trap here. It's too easy and you don't have to think about the question. So if C, here's a graphic from last session if you saw it. If you didn't see it, you might want to go to the archive and check it out. But if the following things are true about choice C, then it's a trap, don't pick it. So it's way too easy. That means that there's like literally no work. You can see right away. So I mean, if you do like a whole bunch of steps first, it looks like this graphic is still loading for most people, but there's a graphic that is on its way onto the board. Looks like it's taking a really weirdly long time to load. Does anybody see the graphic yet? Chat box, tell me if you see it or not. You should see a yellow box with 3 red statements inside it. Does anybody see that yet? You see, okay, because according to what I'm seeing, according to the icons that I'm seeing, no one sees it yet, but okay. Some people see it, so that's good. Does anybody not see a yellow box that says 3 red statements in it? If you don't, then let me know, and I'll try to fix this issue. Okay, so there's 3 red statements here, right? It's way too easy. You find much more information than you actually want, and it completely ignores the key concepts. So notice here, this is way too easy in this problem. If you have both statements together, then you can just, you have the whole sequence without even really trying. You don't even have to find it. It's much more information than you actually want. I mean, again, as we said, I mean, you find way more information than you need. Like in this problem, if you pick C, then you have the entire sequence instead of just an answer to the question that you want. And what's most important here is that if you pick C on this problem, then you never have to think about the substance of the question, which is how many terms are greater or less than 10. I mean, again, if you don't have to think about what the question is asking you, then that is trouble city. So if you have that kind of situation, then it's a trap answer. So don't forget, by the way, ladies and gentlemen, don't forget, if these 3 things are true about choice C, So that would be those three things. Then don't pick C, and then also don't pick what other answer. Like if all three of those are true, don't pick C, and also don't pick what? Yeah, don't pick E either, because for very, very different reasons, right? You're not picking C because that's how they write trap answers. But you're not picking E because it's clearly impossible in these situations. Because, I mean, remember that we're talking about a situation where if you put the two statements together, it's like dreadfully obvious that they are sufficient. And choice E means that if you put them together, it's still not sufficient. So the answer is not going to be E because E is impossible in such situations. So C trap, don't pick C, don't pick E. Extremely common trap, especially if you are a high scorer on the quant section. So let's take a look at another one. How about this one right here? Again, keep in mind what makes choice C a trap. Just keep that in mind. Okay, so remember where your multiple choice answers are found. Those are found here. This problem's got a little bit more stuff going on in it, so I'll give you a little bit of a longer timer. Go for it. Okay, we still have answers from only about 1/3 of the people here, so if you don't have an answer, then you should guess one pretty soon. And when if you have to guess, don't forget what the theme of today is, but take about 15 or 20 more seconds. Remember, there's a couple of you guys typing answers in the chat box. Don't do it. I mean, notice what's up here on the board. This is where the multiple choice answer options are. So if you are Eric or Vidita, yeah, multiple choice options. Okay. Oh, sorry, you guys. Those are not answers to the question. Those are answers to last time. My mistake. Sorry about that. Okay, so here are the choices that you guys picked as a class. Right there. So there's the non-responses there in that bottom row, the Nessuno row. One of those is me, but this means that there are 6 other people who didn't answer the question. I mean, remember that you have to answer the question. You have to, because this is a test that does not let you skip things. So you must answer all the questions, unless you are me, unless you are the moderator. So there's only one of me. That means that there are 6 of you who should have picked an answer who didn't. Okay. There's one response of E. I mean, again, if you gave E, I hope you just got here, because again, the point is the answers to these problems are not C or E, because those are traps. So let's talk about this problem, because we're basically evenly split here between A, B, and D. So that means that this problem is lots of fun. Let's talk about it. Let's talk about the trap answer first. So here, if the problem is way too easy if you pick C, if you find more information than you want, and if it completely ignores the math concepts that are tested. So, I mean, these two things are the most important two things, the first of these and the last. Let's talk about what happens if you pick C. Okay, like let's discuss what happens if you pick C here. Let's consider. If you pick choice C, then that means that this angle is 60. And you also know that this angle is 40. So that means that if you consider, let's just black out this segment that we're not even using anymore. That means that this would be 120 degrees. And so all you have to use is 180 degrees in a triangle. You aren't using anything other than there are 180 degrees in a triangle. I mean, that in itself is not so much the problem because there are a lot of very challenging problems on this test that use nothing but basic facts like this. But what is the problem here? The problem is that if this is your reasoning, that you are completely ignoring what thing? Like if you just say, okay, well, this angle is 180 minus 40 minus 120, then what are you not using that is obviously a huge part of this problem? Chat box, anybody know? Like if you just subtract out of these angles out of a triangle, like what are you totally not using at all? Okay, you're not using AB and OC. You're not using that, but even more importantly, you are totally not using what shape that must be there for some kind of reason. You're not using the circle. I mean, right. So if you pick choice C here, that is what should make the biggest impression on you right away. You should be like, uh-oh. If I do this, I am totally ignoring the circle and just sort of smiling about it. I mean, if you, let's highlight some things here in red highlight. Yeah, so I mean there's this, right, AB and OC, and there's also the circle. That's bad news, right? So if you do this, if this is your reasoning, you are ignoring all the red stuff. Okay, so remember, if you guys are ignoring like 75% of what's in the problem, there's no way that answer is correct. There's just no way. So C is going to be a trap here. You're going to have to use all of that stuff. You're going to have to use the circle. And you're going to have to, yeah. So these are not answers. It's not C because C is a trap. It's too easy. And it's not E for a very different reason. It's not E because that's just impossible. Because E would mean that, I mean, choice E would mean even if you had two angles of a triangle that you could somehow not find the third one, which is not great. I mean, that's not how this works. So if you have to guess, you're going to be guessing A, B, or D here. So now let's talk about how this problem actually works. So there's a goal in the problem. What is the goal of the problem? The goal of the problem is to find that. So, I mean, a good place to start would probably be to define some sort of unknown for that, because that way we can focus on it. So here's x. So then if that's x degrees, then x is the goal. All right, so let's actually do things that involve the facts in the problem. I mean, I know that sounds dumb in those words, but if you are not using the things in the problem, then you are in big trouble. So we know that this is the same as that. But what are those also the same as? Those are also the same as BO because those are the circle. So notice once you have that, then you can be happy that you used the circle. Because again, they are not going to put a stupid circle in there for no reason at all. It's going to be there for a reason. So we know that OB and OC are the same. You should think once you realize that, okay, now I've actually used the circle, which is good because they're not going to draw that for no reason, right? It's got to do something in the problem. So that's, okay, we know that. These two sides are the same, so what is true about this angle right here? That angle is also x. So that should make you feel good too, because okay, now I have actually used the fact that, so if you have the same sides in a triangle, then the angles across from them are also the same. So when you do that, you should feel good about it because, okay, now I've actually used the fact about AB and OC that they gave me. Okay, look, I actually used the fact here. You know that AB equals OC crystal because they tell you in the problem that it is. They tell you that those are equal. There, AB is equal to the length of OC. Okay, so now I've actually used the facts and the things that are there. I mean, that should make me feel a lot better about things. So let's see what happens here. Well, this is a triangle. This guy right here. Let's make that thicker lines. Okay, this weird turquoise colored thing is a triangle. So that's x and x. So 180 degrees in a triangle. So this is going to be 180 minus 2x. Then what else can we do? Well, we can find this thing right here. That's going to be 180, because, I mean, this whole guy right there is a straight line. So that's going to be 180 minus the other part of the straight line. So 180 minus the 180 minus 2x thing. Again, don't be shy about applying basic rules. Like, you might have to go crazy with these triangle things, 180 degrees. So this is 180 in the whole triangle minus 180 minus 2x. So that's 180 minus 180, which goes away, plus 2x, because you have to distribute that subtraction. So those are going to be goners. And you're going to wind up with 2x left over. Oh, and then these are the same too, because these are each of these is a radius of the circle. So that means that the angles at B and C are both the same. Then we can use this triangle, and we can do exactly the same thing we did with the left-hand triangle. We can use that triangle, that orange triangle. So then angle COB is going to be 180 minus 4x. And then finally, we can find this one other angle that is all over the place here. We can find COD. We can just use the fact that, again, that straight lines have 180 degrees in them. So this angle is going to be, it's kind of horrible, but you have to be not shy about applying these rules if you know, because I mean, all we need to do this is to use over and over again the fact that a triangle has 180 degrees and a straight line also does. So this is 180 minus both of those other things, minus x minus the other angle, which is 180 minus 4x. Okay. So that's going to simplify to the 180s go away. It's 180 minus x minus 180 plus 4x. So that's 3x. Okay. Wow, hey, look at that. So all of these things are in terms of x, which is kind of cool if you think about it. So now if you use statement 1, then we can find x because we know that 3x is 60. And if you use statement 2, then we can find x because 2x is 40. So these are both individually sufficient. because the first one tells you that x is 20, and the second one also tells you that x is 20. So both individually sufficient, and so that means that the right answer is D, like dog. Any questions about this problem? I mean, notice that you actually have to use the stuff in the problem. I mean, that sounds like the dumbest thing that anybody has ever told you, but if you don't use the stuff that is in front of you, then that's going to be trouble. Okay. Also note that you should not be shy about using basic facts. John, the sessions are over at 5:30 Pacific, 8:30 Eastern, although sometimes we roll over that by a few minutes. Okay, don't be shy about using basic facts. I mean, if you know things like there are 180 in a straight line, 180 in a triangle, you could just use those over and over and over and over again and fill the entirety of diagrams like this by using those. So that's pretty sweet. Most importantly, note the trap nature of the answer here of C. It's not a thing. So don't let it be a thing. How about this? Okay, if they use quadrant numbers, then they're usually going to tell you which ones are which. So second quadrant is the one on the top left. Remember how quadrants work, right? The first quadrant is where everybody is positive, so that's over here. And then second quadrant, and then you go in the non-clockwise direction for the other quadrants. So there's your quadrant numbers. So the quadrant that we care about in this problem is this quadrant that is right here. Okay, try that. Remember where your multiple choice answers are located. They are here. Please don't type answers in the chat box. Go for it. This problem is shorter, so I'll give you less time. Okay, folks, there's still like 10 or so of you guys without answers, so go ahead and guess something in the next 10, 15 seconds, please. Okay, so let's talk about it. There's a couple of you guys picking C, which means that you might have just not remembered what the theme of the class is. But let's talk about this problem. So, okay, if you pick choice C here, what is your reasoning? Well, let's think about that for a second. If you pick C here, then all you have to do is think about, all you have to do is, this is the equation of a line, where remember that this is the slope, this M is the slope, and this B is the y-intercept. All you have to do, if you pick C, this is all you are doing is saying, look, man, statement 1 gives me this. And then you're saying statement 2 gives me the other thing, which is the B. So I mean that's kind of, and then you're saying I have the line. So yeah, not really going to be how this works, right? So you're saying statement 2 gives me this. So again, let's take a look at our checklist of, oh boy, C is a trap. And let's see what is up with that. So, well, way too easy, more information than you actually want, and completely ignores the key math concepts that are actually tested. So, well, it's way too easy, sure it is, right? I mean, you are just spoon-fed the values of M and B. So that's not going to be how it works. you find much more information than you actually want. Like notice you find the entire line when all you wanted was to know whether it hits a particular quadrant. And then most importantly, if you do this, you don't have to think at all about quadrants. And I mean, folks, the problem is about quadrants. You know, so I mean, if the question is about quadrants and you are just not thinking about quadrants, then that is, you know, an issue. It's definitely not a thing. So just make sure that you are on board with this. So this is not going to be C, and it's not going to be E. So now let's talk about it. So here's the problem again. Remember where the second quadrant is located. The second quadrant is the top left. So now let's talk about these two statements. Well, statement one, also there are actually, I think there are 2 or 3 entire Thursday sessions about coordinate geometry and data sufficiency in particular, a super specific topic, right? But remember with coordinate geometry problems, especially on data sufficiency, with coordinate geometry, your primary approach should not be algebra. Your primary approach should not be y equals mx plus b. Your primary approach should be to just think about what stuff looks like. Because that's why that's one of the reasons why they put coordinate geometry on the GMAT, is because they don't want people to just be grinding algebra all the time. I mean, most problems are about visuals. So, I mean, you can use y equals mx plus b as a backup approach, but only as a backup approach. Because most problems are about visuals. So let's talk about visuals here. I mean, what does statement 1 look like? Like, what does a slope of minus 1 over 11 actually do? Like, how does it appear on a coordinate plane? So yeah, it goes down, as you go to the right, it goes down, right? So the line, I like John's summary of it. For every forward movement, it moves right 11 units. So that's a pretty good summary of it. So John, let's put John's summary on the board. It's hard to take screenshots of the chat box because it moves a lot. Okay, so here is John's summary, right? For every downward movement, it goes right 11 units, precisely. So that means, visually speaking, it looks like this. It's probably even flatter than that, to be honest, but it looks like that. And notice also that lines go on forever, too. So if you go down 1, then it goes over 11. For each 1 you go down, you go over by 11. Okay, so if you think about it, where can you put, I don't know what's in the 11 units thing, it's what a slope means, right? If you, NILS, if you don't know what slopes are, then you should check out the Foundations of Math book. But remember how slopes work, right? The numerator is how much, the top of the fraction is how much it goes up or down, and the bottom of the fraction is how much it goes left and right. So 1 over 11 means up and down 1 for every 11 left and right. That's how you define slope. And then the negative sign means you go down. So if those basics, if you need to brush up those basics, then check out the Foundations of Math book. But you should definitely have an instant recognition of what this means and what the slope signifies. So the point is that the line goes down from left to right. So if you think about whether you can hit, I mean, can you hit the second quadrant? Well, sure you can. Right, I mean, that's not very hard to do. Can you hit the second quadrant? Sure. Like here's the coordinate plane again. Okay, well, can I hit the second quadrant? Yeah, sure I can, right? So there's a line that hits the second quadrant. Can I miss the second quadrant? Yeah, the line goes on forever. So if you think about it, because some people are like, oh, well, if I just put this like 1 billion units down, then I could miss it. But no, because remember, it's inexorable, right? For every 11 you go over, it goes up 1. So if you are 1 billion units down below the x-axis, then if you go over more than 11 billion units, then you will wind up in the second quadrant. So you always have to hit it. So every single one of these lines hits the second quadrant. I mean, again, notice also this is a good solution in the sense that it does not ignore the substance of the problem. I mean, it actually uses all of the things. Like we actually had to think about the slope, we had to visualize the slope, and we had to think in particular about the second quadrant, which is, that's a good thing because the question is about the second quadrant. So we should like to be thinking about the second quadrant here. So because if it was the first quadrant, we wouldn't know. I mean, the first quadrant you could miss or hit. But the second and fourth quadrants you're going to have to hit. So every single one of these lines hits the second quadrant. So statement 1 is sufficient. So that means we are left with A and D. Let's talk about statement 2. Here's the problem on another page. Does line L intersect the second quadrant? Well, so statement 2. So again, here's your coordinate plane. I mean, statement 2 means, visually speaking, that you have a y-intercept of -3, means that you have to hit this point right there, that purple point. That means your line goes through the purple point. But that's all we know about the line, is that it goes through the purple point. So can we hit the second quadrant? Yeah, sure we can, right? If you just make a line that slopes up to the left, then you'll hit the second quadrant. And then can we miss the second quadrant? Well, sure we can, if we just make the line slope up to the right. Yeah, I'll fix that typo in a second. So sure, you can do both. By the way, make sure that you don't think about this as I don't know, because I don't know is not a goal. You can't try for I don't know. But you can try to both miss and hit the second quadrant. That's a big difference. Like, do not think of insufficient as I don't know, because you can't try for I don't know. You should think of insufficient as I can get blah and I can also get other blah. So don't think of insufficient as I don't know, because this is not something you can try for. Instead, think of insufficient as I can get whatever the yes is, and I can turn around and also get whatever the no is. So in this case, I mean, that means I can get a line that hits quadrant 2. And I can also get a line that misses it. I mean, see, this is different as far as strategy. I mean, I don't know is just I'm waving my hands in the air and not knowing. But this is actually a definite goal. So keep that in mind. Let's look at one more problem. We got the time. And then we'll close up shop in about 5 minutes here. So this problem should be pretty quick. Remember that problems that don't have lots of words should not take a long time. So this problem has very, very few words, so I'll just give you about a minute or so, maybe even less to do it. So here's like 55 seconds. Go. Okay, go ahead and pick something. All right, and then this is a quick problem, then we'll be done. I mean, technically it's closing time, but I was a few minutes late, so make sure you get an hour and a half worth of content. Okay, there's a bunch of you still not answering this yet. Remember that you have to answer the problem. I mean, that's how the test works. So if you are not answering it, then, you can't do that on the test. We have somebody picking C here. Maybe that's just like a joke or something, but remember that the whole session is problems where C is a trap. So, I mean, unless you just got here. If you just got here, then yeah. If you didn't just get here, then I'm wondering what you've been paying attention to the whole session. So, but this answer is C here. I mean, remember that the whole point of this session is C is a trap. So if you're the one who picked C, then yeah. I mean, that's not a thing. If you just got here, yeah. If not, then whoa. Okay, let's talk about it. So because if you pick C here, then again, it's too easy. All you have to do is subtract two numbers from 180. And it's not focused on angle R in particular. And then, yeah, you don't have to think about the fact that a triangle is isosceles. I mean, again, isosceles is one of those words you have to know, but even if you don't know what this is, you can probably tell that it's something that is important, because otherwise they wouldn't tell you that. So if you're just doing 180 minus 100 minus 40, then you're just ignoring this important information. So that's a problem. If you are ignoring what's in the problem, that's never a good thing. So don't pick C, don't pick E. So, all right, let's talk about how the problem works. Well, I mean, isosceles, even if you don't know what that is, you should still be guessing A, B, or D here. But who can remind me what isosceles is? Isosceles, what does it mean? It means that two of the two angles are the same. And then also one of the most frequently used facts on the test is that that means that the opposite sides are also the same. I mean, that's not something there's a correspondence, right? If you know that two angles are the same, then you know that the two sides are also the same, and vice versa. I mean, there's no reason that you would have to memorize that, because if you draw a halfway decent diagram, you can just see that it's true. But just make sure you know that these are a correlation. Like if you know one of those, you also know the other one. So, just sketch a few triangles, it'll become clear, right? It could look like this, in which case those are the sides that are the same. And then if those sides are the same, then these angles also have to be the same. Or, you could have an isosceles triangle that looks like this. I mean, that's a very different kind of animal, but it still has the same properties, right? Like these guys are the same. And so then the opposite angle, they're the same. Or it could be something that looks more like an equilateral triangle. So, okay. What do we not know here that is? Yeah, if you just got here, sure. Yeah, that's what I was saying, right? If you pick C and you just walked in, then that makes sense. But if you have been here the whole time, then you wouldn't want to pick that. Yeah, exactly. Okay. So let's talk about it. What do we not know here that is very, very important? So in such a case, do the angle letters matter? What do you think? Yeah, that's what John says. You don't know which two angles are the equal ones. So all we're told is isosceles. What we are not told is which two angles are the same. So in this case, it's totally important. But in this case, it definitely does matter. So it could be possible that R and S are the same. It could be possible that R and T are the same. And it could be possible that S and T are the same. So I assumed RS equals ST. Well, if you assume that, then statement 1 should kind of smack you in the face, because if you assume that, then statement 1 is actually impossible. But, so that should, yeah, right? That's what Mayan says. If you assume that, then statement 1 will smack you in the head. So, okay, well, statement 1, let's look at statement 1. If you have a 100-degree angle, how many degrees are in a triangle? Well, there's only 180, right? So there are only 180 degrees in a triangle. So therefore, if one of the angles is 100 degrees, then it must be the one that's not equal to any other one. Because you can't have two 100-degree angles in the same triangle. So that means that you're looking at a triangle that looks like this, where there is your 100 degrees. And so then there's 80 degrees left over, so it's 140 and 40. That means that angle T is definitely the angle that is unique, and then angles S and R in some order are those. We don't really know which is which, but we don't care because they're the same. So these two angles in some order are S and R. In either order. But again, they're both 40, so we honestly don't care. So in this case, we know that angle T is 100, and so we know that angles S and R are 40 degrees apiece. So the letters, they definitely matter. Angles R and S are 40 degrees each. So this is sufficient because you have the value of angle R. Okay. Now, what about statement 2? See, that's a different animal because 40 degrees is not this thing that can only exist one time. You can totally have, you have to consider two cases here. The first is the case in which if 40 degrees is the unique angle, but then you also have to consider if 40 degrees is one of the two equal angles. You didn't have to do this for 100 degrees because this is impossible for 100 degrees. So, but if 40 degrees is the unique angle, then you have a triangle that looks like, you have a 40 on top, and then you have two angles that are the same. So this is going to be 40 180 minus 40 is 140, so these are going to be 70 apiece. But then it could also be the case that 40 is one of the two equal angles, in which case, if that happens, then you're just going to have the triangle that we already drew on the previous page, which is this triangle right here. So let's color code those statements. Okay, so if you have the green case, then you have the green triangle, and if you have the blue case, then you have the blue triangle. Notice that in this case, this is going to be angle S, and in this case, S is one of the bottom angles. So, but in this case, you know that angle R is definitely 70. In this case, angle R could be 100 or 40, but the point is that it's not 70. So the point is that we definitely have two different possibilities. So if this could happen, and this could also happen. So not sufficient. So I mean, yeah, and I mean, let me just come back to this question before we close up here. Here is the question that Yannick is asking. In such a case, do the angle letters matter? I mean, if you think about it, think about the theme of this session. I mean, we're specifically talking about C being a trap. But more generally, the reason why C is a trap is that the stuff in the problem has to matter. So a very good general way of thinking about this, it's going to sound dreadfully obvious in these words, but if there's stuff in the problem, it should matter. I mean, you know, whatever the stuff is. Like if they specifically say angle R, then it probably matters that they're talking about angle R. If it says the second quadrant, then it probably matters that it's the second quadrant and not the first one. If they say, etc., if they say the tens digit of a number, then it probably matters that it's not the other digit. So, I mean, this is basically what you should have in your mind. If there is stuff, then you should think about that stuff. Again, it sounds obvious, but, you know, there are lots of people who don't think about the stuff in the problem, and that's what causes all the trouble. Okay. So that's your general idea. Just remember to focus. Focus on things. And if they talk about it, think about it. All right. Thank you for attending. And we are going to wrap up here. We're actually way over time, so thanks for coming. What is the chance of? I don't know what quadratic geometry even means, but those sound like two very different things to me. Like quadratic sounds like algebra and geometry sounds like geometry. But if you want to submit topics in the submission form, please do not submit them here. Okay, we're going to go ahead and wrap up I'm going to turn off the recording and